Mykel Alvis, a good friend of ours from Cotivity. And okay, Mykel, it's good to see you live.
You and it seems like years now.
Yeah, I know. It seems like I used to see you every couple of weeks. Mark was standing here behind us.
Right.
So, yeah, we used to see you, it seems like every couple of weeks at conferences, and then I couldn't make it down to Atlanta. I think you were at Dev Nexus back earlier in the year, and I was off somewhere else at some other conference. So
it's almost like work, man.
Yeah, I just think back to the taco place in San Francisco and the heavenly tacos that we had there. So
yeah, I'm gonna miss the fact that DevOps Enterprise Summit isn't there this year.
That's right. We're gonna have to find a new taco place in Vegas. So if anyone has recommendations on Slack that you can drop us for where we need to go and get tacos there at DevOps Enterprise Summit in October, we'll take the recommendations. So Mykel, glad you could join us. Mykel, a longtime Nexus user. I've seen, like many of the speakers that we have on today, I've seen speak at different conferences that we've both been at, but I don't think I've seen this latest presentation here. So yeah, so we might. Are we the test run for this?
But you're the first one that I can't shame into silence, and that's what really matters.
Excellent. So why don't we can see you, we can hear you. Why don't we get you to share your slides, and we can kick off this the conversation with you.
Apparently, I need to share my entire screen. I need to do this, and then I need to do that, and. How are we looking?
Perfect. You are golden.
Great. Hi, everybody. I'd like to thank Derek and Mark and everyone at Sonatype for the opportunity to speak today. This is a very different presentation from some of my other presentations. Usually, I'm just basically a giant jerk and call people names. This time, I'm only going to call people names. I think I'm not being a jerk that much. But this particular presentation started out something very, very different. It started out as a more philosophical, conceptual thing, but over time it became something about specific technologies. And I think it actually resonates, but it can be very challenging to grasp the whole point. So I am perfectly willing to spend time explaining it afterwards, assuming that I don't get my point across. So. The real deal here is that pretty much everything sucks in software. It is a giant pit that is trying to destroy all of us all the time. It's eating everything in the world. It makes everything good and everything bad. I love Amazon Prime, but the truth of the matter is that I also like corner grocery stores. So as we proceed forward into the future, I can only expect that everything is going to continue to suck even more, and that we will try to produce some sort of magic in software that reduces the suckage of everything that we can find. I am Mykel Alvis. You can find me pretty much everywhere as at Mykel Alvis in some way. I am the DevOps coach for Cotivity Labs. Labs is the R&D function for Cotivity, which is one of the leading providers for payment processing accuracy in the healthcare claims space. So I work with extremely dangerous data. I work in a very aggressive environment, and I work as my job is to reduce risk in that environment as much as humanly possible. That has been the job that I've had a lot for the last 14 years, but I have been a software engineer for 41. I'm starting in my 42nd year as a developer. And across the last 14 years, I have been deeply observing the process engineering space. I have about 40,000 hours of work in that space right now. And that is not one of those moments where I go, you should listen to me because I am an expert in this space because I have more than 10,000 hours in it. That is not the case. The reason you should listen to this is because of how many times I've screwed up across that time and before it. I've given a number of presentations about the ways that I screw up. I've given a number of presentations about the ways that I have pulled myself out of that mud. And this particular one isn't one of those. This is just a new thing that we do, a relatively new thing. You, on the other hand, have a job. You're trying to create order from chaos. You probably have a lot of trouble with repetition. Repetition, humans love it, but they're not really particularly good at it. You're trying to merge some operational discipline with some development work. You're basically trying to merge change with static behavior. And probably you're held accountable for the results. If you're here, this is probably interesting to you because you're looking to reduce the risk of this problem. Now, we could start at the very, very beginning. First, there was this big explosion and the universe came along, but I'd prefer to start in about right around the mid-90s. So I've been writing software since the 70s, but it was really terrible until the mid-90s. In the 90s, we had a lot of then software became a new thing. It became a much more compelling behavior in society. Computers became cheaper. It became more prevalent and pervasive within business, and the tooling started getting a lot better. The introduction of Linux was in most of that period. There was a big shift in the middle of the 90s. There was this thing that Sun did called the JVM that gave a relatively isolated runtime in a space where that wasn't the case anymore. It had not previously been the case. And so most of my work since probably 1997 has been in a space that is in or around Linux and the JVM. And for that period of time, if you are familiar with the breadth of it, tooling started out being really, really terrible, actually non-existent. When I was in the beginning, I built with make files. Actually, I built with shell scripts. Actually, I built with batch files. And so as we proceeded forward and the tooling became more important, there was this sort of cultural shift about tooling that pushed us toward a more unified way of dealing with our software problems. Tooling wasn't even remotely big. The biggest thing that I can remember in the 90s before the JVM was Rogue Wave tools, which cost a fortune. It was a giant C++ library that had 12 feet of documentation and was really difficult to use most of the time, but it was basically the tooling you had, that and make, people. And so we've got this kind of push toward tooling, and tooling is really a great thing. And tooling helps us impose determinism. Now, determinism, in a general sense, is unavailable to us. You don't control the underlying physics of the universe, so nothing is truly deterministic. I also believe that chaos is only sort of a thing, though. I think everything more or less happens for a reason. I think that there's probably some, series of atomic collisions that occurred that made me show up at this thing today. And probably those things could have been predicted if I was way smarter and much more perceptive than I am now. But chaos is just sort of a thing. Imposed order is sort of desirable. You don't want statically, externally imposed order. You kind of want to make your own order. You want things to sort of work the way you want them to. And tooling helps you do that. Tooling helps you increase the order and thus increase the determinism and the predictability. And the reason you want predictability is because it allows you to keep your promises. Now, people tend to work because, or they tend to be in software because they have work, and they tend to work because they get paid, and they tend to get paid because they do real stuff. Employers have a strong tendency to look negatively on it when you don't produce those things. When you're not capable of delivering results with some frequency, it can be very challenging for an employer to consider your continued value. You, as a consumer of tooling and software, are really looking to produce some degree of predictability so that you can provide some assurance to someone. So collaborative assurance is actually a really big outcome from good tooling and from good tools and from good processes and practices, which are themselves cool tools. So when we talk about promises that we're making to people, promises they come in a wide variety. This is the Webster's definition because I needed something to put on the slide, but they really are this is really kind of it, right? It's a reason to expect something, especially something with an expectation of success. When I promise you that I'm going to show up to your birthday party and I don't show up, that makes me that I've let you down. I've actually broken a minor social contract. You know, I probably had a good reason, mostly because I didn't want to come to your birthday party. But as a tool, as a way to handle social interaction and actually non-social interaction, even technical interaction, promises are a sort of a really big deal. Some of you probably are aware of Mark Burgess's work in promise theory, which has a much wider reaching implications than just in software. But to be honest with you, that it turns into a philosophy discussion at that point. And mostly what I do is I have a job and my employer expects some results, and therefore I'm interested in it because it produces some kind of outcome. I have systems. Those systems, rather than being constrained by their promises, they are actually, what they do is they actually reduce the number of promises they make. And we do a really good job of trying to keep those promises. Promises actually do this really cool thing. They give you autonomy in decision. You can decide whether or not you're willing to accept a promise that somebody wants you to make. If you have a significant other of any sort, probably what happened is somewhere along the way, you asked them to make a promise to you to attend some event. We'll call that event a date. And under those circumstances, that person probably showed up. Now, they didn't have to. They chose to do this. The act of choosing actually produces a positive output. Humans get dopamine responses when people actually do things that they say they will do. You like it when people keep their promises. And this autonomy is this autonomy of choice means that it's not a compulsion. It's actually something that we want to do. And this autonomy exists within a potentially complex space-time, you know, like the real world, which is an extremely complex space-time. There's a lot going on here. Again, I didn't show up at your birthday party because I didn't want to, but I really didn't want to because Westworld was on. So it was there's a lot going on out here, and we don't always have the capacity to understand the scope of what we're agreeing to. But when you make a promise, your social capital is bound to your ability to do this. Everybody has this person in their life that never keeps their word. They never keep their promises. Heck, they don't even keep minor social commitments. We're not talking about laws here or SLAs where, you know, jillions of dollars get lost. We're talking about your friend Tony, who he can't be bothered to show up to the movies that everybody was going to. He can't return phone calls. Everybody has this friend. Probably, if you don't have any friends like that, as the saying goes, you probably are that friend. And so it is truly important that to maintain correct social capital and live within the construct that is society, that you have to be able to keep your promises. This is, I mean, like, I know this sounds very kindergarten, like don't promise what you can't deliver and all that sort of stuff. But this has really serious real world implications in software. The way that one of the better ways to produce a delivery that keeps the promises is if you produce something that is in fact immutable. And I'm going to explain why that is. There's this promise. I promise you that this system will stay up 7 nines. Okay, well, because I'm an idiot, I decided I would accept 7 nines of uptime. I promise you that it will. Now, the amount of change that is in that system, the amount of delta that goes through that system and that gets eaten in that system induces some of this chaos that leaks in from the outside of the world. The more that leaks in, the more likely that there is to be something that you didn't take into account. So the less change that you do in a thing, the more likely it is to stand, well, let's say in that case, 7 nines is basically permanent in the scheme of things. That as an output, the immutable delivery of a thing allows you to reason to some degree about whether or not it's going to stay alive. Now, we work in a cloud environment, and to be honest with you, sometimes that thing goes down. I don't have any control over that. I like not having any control over that because I like not running a data center, and I like not racking and stacking hardware, and I like not having to push and pull network cables But there is a little cost to this, right? So now we're down to the question about determinism and why you aren't really deterministic. You don't control the underlying physics of everything. If you did, you'd be amazing, and you would never have downtime because you would simply will it not to be so. But in the course of determinism within your system, what you're really trying to do is get down to the level that you are capable of controlling. And that's where you make your promises. I promise that as long as my cloud provider provides this thing, that I will attempt my best to do this other thing, like keep your system alive. And to do that, I frequently have to produce something that is relatively immutable, or I've got a moving target on my hands. Now, we handle this in the course of producing things through builds. Most of my process engineering life has been in build and build management. I believe very deeply in a build-centric outcome. I believe that in the course of a build that you can make a lot of decisions and you can keep a lot of promises by simply aborting a task. We've had several people talk about how they abort a process before something terrible happens, before a bad piece of software gets included as a dependency, before an untested piece of code goes forward, before anything happens. When you get to the deployment of a thing, and deployments are themselves nearly as durable as they used to be, but when you consider that by the time you get to the deployment of a thing, you're really committed to a certain degree. So you kind of want to push as left as you can. You want to make the fail happen as fast as possible. You really want it to happen before anybody tries to do anything of any real value. And that's where the systems that we are building right now are based. The concepts are based on the idea that we are trying to produce.
It looks like we may have lost Mykel there. We're going to get him back on in just a second. Yeah, once we'll get Mykel back on the Slack channel, let him know that we dropped, and then we'll go live again. Sorry for the inconvenience here. Sometimes happens in a live environment.
Hey, where was I?
Sorry. Hey, Mykel.
Where was I? What thing did I say last?
You were just had passed the slide with the life cycle on it.
Okay.
So
cool. I'm back.
I was just tweeting that you were doing a great job. So
and then it turns out that the tab sleeper in Chrome is a weird thing. Let me see if I can make that just not ever happen.
Okay.
Disable that. Before we move forward, I'm going to just disable this thing. I think I'm going to disable this thing. Let's say that.
Yeah, no worries. We can edit this gap later in the presentation. We're just taking a lunch break, so we don't. We're not preventing anyone from speaking.
Okay. Well, great. Yeah, I can't figure out how to make this happen. I'm not that smart, so I can just if I die again, then I will try to just ping me.
Well, at least you know that you died. So.
I know I died. No, and I do now. Actually, Amy told me. So we're back. So I'm going to go back to sharing and this and that. How are we now?
We are good.
Okay. So again, to reiterate, because repetition, process induces deterministic outcomes. Determinism induces predictability, and predictability allows us to keep our promises. And fortunately, I used a pejorative in the middle of that, so it's probably pretty good that I was off. Our definition, my team's definition, is anything that meets your release criteria, whatever that is. You can have a bunch of criteria. We have a bunch of criteria for what our release criteria is. People work on software all the time, but until it gets to the point where they have met our release criteria, it's not a real thing. It's just kind of, whatever. Sure, bro, you got some cool code. Great, congratulations. For our definition, a release produces an immutable artifact that we store in a known location with a unique and versioned identifier. If this all sounds very Maven-centric, well, congratulations, you made it to the party. Releases also imply a process, some mechanism that produces this. Within our system, it is always a Maven build. It is a Maven 3.5.3 build, to be specific. It is always a Maven build. We don't build any software any other way. Now, I have worked in a lot of teams across time. And everybody that shows up on my team is like, oh my God, why we build Maven? It's so terrible. I'm like, well, it's because you don't know what you're talking about. Because I'm not looking for things that make life easier for you. I'm looking at things that make life easier for the company. I am looking at this from a purely holistic viewpoint. Now, can you get the same results with another tool? Of course you can. Of course, it's Turing complete software. You can do it with bash scripts if you want to. In our case, we do Maven releases because it has a formal release process and because we have a system that does it by bots. So our releases are actually untouched by human hands. And we treat every single thing as if it was software. Everything. We treat everything like it was software. We build it, we test it, release it, and then we deploy it. We keep our releases safe and we never change them. They are as immutable a thing as we can possibly make them be. Again, at the constraints of determinism. Our criteria are that we follow the Maven release formal release cycle, which is for people in the know in that space. It's a release, prepare, release, perform. We require a specific amount of test coverage on your application. I prefer 100%, but I'm also not insane. Well, possibly not insane. We'll see. And then we have a bunch of security stuff that we want to pass in this process. When we have security scanning in your build process, suddenly vulnerabilities can be sort of a software problem. We can actually talk about these things as if they were deficiencies in the software rather than some behavior that some person made. We build our stuff with our bots and we deliver it specific to our repository, which in this particular instance is, as you guessed it, Nexus. Now, I've used Nexus for a really long time. I've used a bunch of other repository managers, and to be honest, well, there's reasons. So our promise, we really produce one, but we have this kind of secondary one. The promise that I make my people is not, I will keep your application running. I'll try, whatever, but I'm not promising anything. I promise that I will do everything I can to ensure that access to a given released artifact remains possible within the constraints of our information retention policy, obviously. This is actually a fairly low risk promise. It's actually pretty easy for me to do this. I restrict the people who could possibly make that not happen. I have a team of people who are able to make it happen, who simply won't make it happen because they know that we have made this promise, and we're all kind of on board. We have a social construct that says, hey, I'm not going to delete the blob store that backs Nexus or anything in it. And that's a pretty easy promise to keep because it's a promise to not do something. It's not a promise to do something. It's a promise to avoid a potentially damaging act. The other thing that we promise is we're going to keep your system alive for just about as long as it takes to replace it. So if it took 2 hours to deploy your system, I'm going to try to keep it alive for 2 hours. That's my promise to you. So we'll keep it alive. But if your system keels over right at the end of deployment, it only runs for 20 seconds and then it keels over, then right as soon as I start deploying your stuff, I'm going to try to start deploying it again somewhere else. That is a substantially riskier. It's not actually slightly riskier. It's a substantially riskier behavior. Now, for the shameless plug part of the presentation, why did we pick Nexus? There are other repository managers. We've used them. I've used them. Our teams use them. Repository management isn't really optional in modern software development. If LeftPad taught you nothing as a JavaScript developer, having a repository manager is super helpful. And because modern software management is done in a dependency chain, these things all kind of understand each other. Sonatype has a substantial amount of experience dealing with this problem. They focus on how these things are proceeding forward. They have good features and they build new, intelligent new features. Honestly, the reason we keep it is that I have a great deal of faith in the stewardship of the application itself, of specifically a repository manager. I have a great deal of faith in those people because they have, you're sitting there looking at them a lot of the time in this conference, but those people have never let me down, literally never let me down. Now, the first time they do, it's going to be kind of crushing, and they will eventually, but it's not really, I don't really expect it to happen anytime soon. In fact, maybe not into my lifetime. But the primary reason that we pick Nexus is the reason we pick any repository manager is because packaging is literally everything. In software delivery, packaging is everything. There is nothing beyond it. We talk about containers as if they were a magic new thing. That's just a package of running stuff, or a runnable package of stuff, or however you want to call it. It's an executable for practical purposes. Well, Ruby gems are this amazing package. No, they're not. They're just another package. They have dependencies. They all work, right? Maven built POMs are descriptions. They're models of packages. Yep, that's all they are. So packaging allows you to collect things in an intermediate form with a temporal and interface signature identity. A thing that you can you can reason about the identity of the contents of a package by simply looking at its identity. And you can look at it in relation to the identity of other identities. If you don't know how this works, then go look at a Maven POM, or go look at a gem file, or go look at an RPM spec file and see about how all the different versions of things interact with each other and how they expect to be able to interact with each other. The thing that makes good packaging is veracity. Is it verified? So did you sign your package? Did you test it before you put it all together? Is it easy to do correctly? Is it simple? Is it hard to do correctly? Like, I don't know, Python packages tend to be. Is there one right way to do it? Again, Python. Is resolution capable? Can you make this package deal with other packages that it requires? And is it relatively self-contained, or did you need to install this particular package onto a particular machine that had a completely different set of packages that didn't have anything to do with this package? Like, for instance, if you had let's say, for instance, you had an executable .exe file for Windows. In order to run an exe file, under most circumstances, you need a Windows runtime, which means you have to have this other container. It's not really self-contained. Most things aren't. The Java jars aren't self-contained. They need a JVM to run them. But self-contained can be a much bigger problem to deal with. That's last on the list. So the question might be, what's this talk about again? So it's about packaging, to be honest with you. But it's about packaging everything, code and infrastructure code and data and documentation, and resolving those as a running system. Now, people that I work with think I'm crazy. They think that this is too hard. They think that this is not worth doing. I not so respectfully disagree. So our path in this is we do base image cadence. We build binaries based on some known set of code, updated for security purposes, updated for on a cadence. So we release these in a cadence. And then we layer additional stuff on top of them. And then we might deploy them, but we only deploy our stuff out of Nexus. If it isn't described in Nexus, it's not a thing to me. That's not a real thing. If I can't deploy my code out of Nexus, you have some toy code that does not fit within our system, and I don't really feel like talking to you, and I'm sure as heck not going to help you. Now, the key piece of this is that you can redeploy this stuff out of Nexus because, again, we do this out of releases, and what do we not do with releases? We don't ever get rid of them. Our promise to you is that we maintain accessibility. So in the future, I can deploy this software again, usually in a very, very equivalent format. Why do I keep talking about packaging? Well, all of our code produces packages. Right now, our code produces Java. We're a JVM shop primarily, and we produce jar files and tarballs for Python. Some of our packages are done with custom types that we built. We have a bunch of configuration management package types that run configuration management tools based on the contents of that. We do a bunch of testing based on the contents of configuration management. We do a bunch of imaging based on types that we built out of from Maven that generate outcomes that then allow us to make predictable results about what's going to happen. We also do it with data, but unfortunately, I'm not allowed to talk about how that works for a couple of reasons. Now, so we build this cadence, we layer everything into a maximally configured file system, and the deployments just involve injecting runtime configuration. We used to have this super long 29-minute process where we deployed our application. That's about 39 seconds now, I believe, at last guess. Because we bake all of this work at the beginning. We built an image, we tested that image, we decided it was okay. We already knew this. And everything about it lives in Nexus, so we already know where everything is. It just has a GAV that we just point at and go, there it is right there. That's the one we're going to deploy. It has a version chain of dependency described by that GAV and thus produces some relatively deterministic outcomes. But some of it is hard. So naming stuff is super hard. Doing names correctly are really hard. People have, the classic joke, there's two problems in computer science: cache invalidation, naming, and off by one errors. It is. Naming is super hard. Defining abstract packaging types that don't exist in the moment can be very hard. I had to define a packaging type for Packer images. And that turned out to be a really weird problem because the actual things themselves don't always live as binaries that you can access directly. Keeping it clean is hard because people have a strong tendency not to keep things clean. Developers always want to play with fun new toys. And it's like, this is just not a fun new toy. This is the thing that makes your work go smoother. Operators feel constrained to get stuff done. And so they're like, oh, this doesn't do exactly what I'm doing, so I'm just going to go around the process. This can be hard. And everybody has one of these. They got a manager who just woke up with a brilliant new idea that's going to revolutionize the world and makes everything that you've done so far really hard to do. The things that aren't hard. Managing Nexus is not hard. It's practically effort. I think we should probably spend 20 minutes a month, maybe, doing this. Maybe. It turns into 30 if we have to do an update. Resolving the output, it's trivial. Executing the process itself, we have a bot for that. Auditing the outcomes, they're self-auditing for practical purposes. We have logs, and then we have the immutable source of those things. So what are we going to try next? First, we're going to try to open source some of these custom types. We'll see how that goes. My company's not really big on that right now, but I'm making some inroads in that. Anything I lied about just now, which I don't really mean to have, I'm going to try to fix that before I do that, obviously. We need to do secrets management because everybody knows that's hard. And we're going to try to do this. We're going to try to help other people understand how this process works at the very, very atomic level, which is sort of where we're working at it. We're not looking at it from the terms of like, hey, Jenkins can make magic happen. I don't give a crap about what Jenkins does. Jenkins' job entirely is to tell me whether the PR builder worked or not. Did you pass your PR? That's really what I use Jenkins for. I don't use it for anything else. So there is some reading you might want to do if you get this presentation. The Creativity Delusion is a series that you can really watch. It talks about how everything is really based on everything else. Read Mark Burgess's work. Read the plugin guide for the Maven release plugin. The Infrastructure as Code Wikipedia article, and especially Martin Fowler's work in that. And there's a Sonatype article that has some really terrible formatting about building customized artifacts in Maven that can help you move forward. Thanks for your time, and I will be in Slack if you have any questions.
Hey, Mykel, that was a great presentation. Stay with us for a couple of seconds here. So, yeah, that was... I always love hearing you present. One, because you're not afraid to tell it like it is. I think that I took a lot of notes during that presentation, as I have been all morning. But I think the key thing that you really hit on here and continue to hit on is, when people talk about, and you talked a lot about, here's how we do things, and why we do things, and what our process is, and why it's a process, and why we have promises in that process. And you tied it to this, idea of there's a social construct here that we're forming. And that, that concept really helped for me, and hopefully tied, for other people here, this, the relationship between the culture and the tools and the processes, right? This, a lot of people talk about, let's automate, let's use this tool, let's do this, because it's cool or whatever. But you're really, when you're trying to do releases, when no human is touching these releases that you have, right? The social constructs and the promises are what you're setting up in that build process. And it is a social platform, if you will, or a social CD pipeline that you're building, that you're delivering upon. And I think that the way that you were able to match that in the beginning conversation of like, how do we set promises? How do we deal with relationships? Why are those important? Really came out. So you just did a bang up job here. I really appreciate that. I love learning from you and others like you in the community. So super job. We'll be over in Slack I'll be over on my other computer here. But again, thank you for joining us.
Thank you.
Super talk. And I'm glad we had you on. We're going